Hello and welcome. In today's lesson, we will discuss how to find the equation of a quadratic relation in vertex form when given its graph. So I will explain this through two slightly different examples. The first example, we are given this graph. It's a parabolic shape, so it represents a quadratic relation. To find its equation, we always start from the vertex form of the quadratic relation, which is y equals a x minus h squared plus k. In order to find the equation, or finding the equation means to find or to identify the coefficients a, h, and k, substitute them into the equation, and then you're done. Now, in order to identify the coefficients, we need to understand or to know their meanings. So let's go over it very quickly. Remember that the coefficient a will determine the stretch of the quadratic function graph, and it is closely related to the step pattern. We know that the step pattern for a basic parabola, and that's where all the parabolas are built on, is 1, 3, 5. And you find the step pattern always by moving over 1, and this will indicate how far you move vertically. Okay? So, the next coefficient is the coefficient h, and coefficient h indicates or determines the x-coordinate of the vertex, or at the vertex. And k indicates the y-coordinate of the vertex. Whenever I try to find the equation of a quadratic relation, I always start from h and k, so that will be my step number 1. So on step 1, we identify the vertex, or to be more precise, the coordinates of the vertex. Just by looking at the graph, then you can tell that the vertex, which is either the lowest or the highest point on the graph, there is another name for a vertex which is very meaningful and very important to know. It's also called a turning point, and you will use this term more often in grade 12. A turning point is when a graph is going from going down to going up, so it's making a turn, so it's going in the opposite direction. And it can also be seen otherwise as when you have a parabola going this way, the turning point will be right here at the highest point, so it's always when the parabola changes direction. But we'll talk to more extent about this when you go to grade 12. Now, the coordinates of the vertex on this case are, I'm just going to drop a perpendicular on the x-axis to identify them, x equals 1. And for the y-coordinate, I drop a perpendicular on the y-axis, so it seems that y equals 1 as well. So with this, then I understand that h will be equal to 1 and k will also be equal to 1. Step 2, we need to identify the coefficient a. To identify the coefficient a, I use or start from the vertex, and I check and see what the step pattern is. The way we identify the step pattern is this. Starting from the vertex, we always move over 1. You can move over 1 from the right or from the left, either or. And then you move vertically until you hit the next point on the graph of the parabola. And then I'd say to go to the next point on the graph of the parabola, right here, I had to go 2 units. So I would say that I had to move over 1 up 2. And from that same point, then I move over 1 again, and then I continue moving vertically until I hit the next point on the graph of the parabola. And then I count how many units I had to move. So 1, 2, 3, 4, 5, 6. So it seems that the next step was 6 units high. I don't have more room actually to look at the rest of the points. So I'm going to stop it here, and I will say that the step pattern I found so far is 2, 6. And then you compare the step pattern of this particular graph with the step pattern of the basic parabola, which is 1, 3, and you continue on 5, and so on and so forth. Now remember that to go from the basic parabola to this one here, we must have multiplied the step pattern 1, 3, 5, 7, and so on by a coefficient, and this coefficient is the coefficient A. So to go from here to here, so from basic to the transformed parabola, this is basic, this is transformed, we must have multiplied the step pattern by the coefficient A. So what number do you think we have multiplied number 1 by to get 2, number 3 to get 6, and so on? It seems that we get consistently the same coefficient, the coefficient A equals 2. So therefore, we're going to say that the coefficient A, in this case, equals positive 2. And I'm going to write down the step in here. So identify A by using the step pattern. And now I would say that I have everything that I need to write the equation of the quadratic relation presented by this graph. And I'm going to go ahead and write it down right here. That would be my answer. So y equals to x minus 1 squared plus 1. And I always like to box up my answers because I like that when they stand up. When I stand out, gosh. All right. So we're moving on to the next example. So this is the graph that we're given here. And again, I'm going to start from the fact that the quadratic equation that I have to find will be in the form y equals a x minus h squared plus k. And I'll start working on finding each and every coefficient. The first coefficient that you want to find at all times is the coefficient, the coefficients h and k, or are the coefficients h and k. So step 1, same thing as we did in the previous example, is identify the vertex. And by looking at the graph, I can tell that the vertex, which is right at this point here, will have the x-coordinates. So to find the x-coordinate, you just drop a perpendicular on the x-axis. It's usually quite obvious. And the y-coordinate will be, sorry about that. So here we are. Remember that 4 squares here represent 2 units, so 2 squares 1 unit. So if you are at 4 in here, that must be 5. So another thing that you need to pay attention to is the unit measurements used on the graph, because they can trick you sometimes. So the y-coordinate here will be -5. So then I know that the vertex for this graph will be at x equals 2, y equals -5, which means that the h value will be +2 and the k value will be -5. And now I'm moving on to step 2. Remember what step 2 was about: finding the value of a. And remember how we did that. So we went at the vertex, and then we tried to move over 1 unit, and then moved vertically until we hit the next point on the parabola. Over 1 unit, the next point. Over 1 unit again, and then the next point. And I'm going to point at the points that I was able to hit in here. So here we are. So over, let me make this a little smaller. So we go over 1 unit, and then we go up. Over 1 unit, we go up. Over 1 unit again, we go up again. Over 1, up, and I will stop there. Now our task is to find out what the vertical step will be. You know, we always move horizontally by 1. Now, as you can see in here, it is not so easy to measure or to eyeball with accuracy, with high accuracy, what the vertical step is. So what do we do in a case like this? We follow a different approach in this case, and we call this an algebraic method of identifying the value of a. And this is the way it goes. You're going to write the equation that you have built so far. So y equals, we don't know a yet, so you write a, and then x. You know that the value of h is positive 2, so minus 2 squared, and you know that the value of k is negative 5, so minus 5. And then we're thinking, okay, so what's my unknown at this point in time? My unknown is the coefficient a. The next question you ask yourselves is, how can I find a? So what do I need in order to find a? In order to find a, you will need an x and a y. So if you had an x and a y, or in other words, if you had a point on the graph whose coordinates you can locate easily and with high accuracy, then we can plug that point into the equation. So we can plug the y and the x into the equation and then solve for a. So let's search for that point. And I would say that I've already spotted one. It's right in here. And it seems that here we have a point. I'm going to call this the point P, one of my favorite letters of the alphabet. And the x coordinate here is 6. And for the y coordinate, just be careful again, because as I mentioned before, it depends on the scale. I will go on the y-axis, and it seems that we have 1/2 in here for the y value. So we're going to say 6 and 1/2 are the coordinates of point P. So that means that we can substitute y by 1/2 here. And we can substitute x by 6 here. So the equation now has changed to become y, or 1/2. You can use 0.5. As long as you are not rounding a fraction, then you can use it in your calculations. Equals a that we don't know, 6 minus 2 squared, then minus 5. As you see in here, you only have one variable to solve for, the variable a, which is our coefficient, right? Constant in the equation. And we're going to solve. So here we go again. We have 0.5 equals a. 6 minus 2 squared is 4 squared minus 5. Now I will isolate the term that is carrying the variable in here, so this one. And I will take negative 5 to the other side of the equation. So we have 0.5 plus 5 equals 4 squared is 16, so 16a. In other words, we have 16a equal to 5.5. And a will be 5.5 divided by 16. Or even better, 55 over 160. And 55 over 160 would equal, in reduced form, 11 over, I'm just going to take it up here, sorry about that. So reduced by 5, so that would be 11. And down here, 160 divided by 5, so we have 5 goes into 16 3 times and into 10 2 times, so 11 over 32. So now we have our a value, which means that we're ready to state our final answer. And we'll say that the equation will be y equals 11 over 32 x minus 2 squared and then minus 5. Okay. Now the questions won't get more difficult than this, and I hope that all this made sense. And I hope you enjoyed this lesson. You have some practice questions that you can complete independently. And that's it for today. Bye for now.